Right now, everything you are, your hands, the bones under them, the breath going in and out, every scrap of it is built out of protons and neutrons, little bricks. Stack enough of them, wrap some electrons round the outside, and you get an atom. Stack enough atoms and you get a person. And that comfortable picture rests on one quiet thing I've never once questioned, that a proton is a proton, solid, small, a thing. The ground floor of the building with nothing underneath it. That's exactly where I'm standing this morning, on the ground floor, feeling, for once, like I know precisely what I'm made of.
It's a lovely place to stand. Warm, well lit. I'd almost hate to be the one who tells you the floor isn't there. Except they aren't bricks, they aren't little, and they aren't solid.
You just took all 3 words. That was 3 words. Brick, little, solid, and you binned every one of them in a single breath. I handed you the safest sentence I own, and you set fire to it while I was still admiring it.
I did. And I'll do it slowly enough that you can watch it burn. Because this is the best fire in the whole season. Come inside one with me. Pick a single proton, one of the countless ones in your thumbnail right now, and let's shrink down small enough to walk into it. Before we go, tell me what you expect to find in there.
Nothing much. That's the whole point of a brick, surely. You go inside and it's just more brick. Proton all the way through like the middle of a cannonball. Dense, packed, the same dull stuff whichever way you turn. That's what the word solid is for.
That's what you expect. Here's what's actually there. You step in, and it's nothing like that dull, still lump. It's dense, yes, but it's restless. Humming, seething with a kind of caged energy, never once sitting quiet. And whirring about in there, not the same dead stuff whichever way you turn, are 3 tiny things. 3, not a smaller lump of proton. 3 separate little objects, tearing around inside the thing you'd been calling solid.
3 things. Inside the brick.
Inside the brick. And here's the part that should tip your chair right back. Those 3 little things are what's actually fundamental. Not the proton. Them. The proton isn't the bottom of the building at all. It's a room with 3 tenants, and the tenants are the true ground floor. So this thing you're made of, this thing you've been calling a solid brick your whole life, it isn't really a single thing at all. It's a committee.
A committee. You've reached into the most solid object I know and pulled out a committee of 3.
3 members in permanent session, never once adjourning. And you're built out of countless numbers of these little committees, all busily meeting away, every one of them packed tight and never still for a heartbeat. The brick you thought you were is closer to a swarm that just happens to hold its shape beautifully.
Right, hang on, I need to sit with that, because it's genuinely doing something to me. This chair I'm on, the floor under the chair, all committees, all restless, all humming. Nothing I'm leaning on is the still, simple thing I take it for. It's a swarm of busy little things keeping up appearances, so convincingly that I lean on it without a second thought.
Keeping up appearances is exactly the phrase. The solidity is real enough to hold your weight, but it isn't the solidity of packed stuff. It's the solidity of 3 busy things refusing to be pushed together. And now the twist that turns this from a curiosity into a proper mystery. The thing I want lodged in you before we take one more step. You cannot take one out.
What do you mean I can't take one out? There are 3 of them, in a room, rattling about. If there are 3 things in a box, I open the box and lift one out and hold it up to the light. That's just how boxes work.
Not this box. You can point at all 3. You can measure them, weigh their effect, chart every move they make. But reach in to lift one out on its own, to hold a single one up to the light, and you can't. Not because your fingers are clumsy, because nature will not allow it. One of these things, alone, in the open, held between finger and thumb, has never been seen. Not once. And there's a reason, and it's one of the strangest rules in all of physics.
Now that's not fair. You show me there are 3 things in the box, and in the same breath, forbid me from ever taking one out to look at it properly. That's the universe locking the display case and pocketing the key.
It's exactly that, and I'll be honest and tell you I'm not picking that lock today. The why of it is a story we've saved for later in the season, and it deserves its own evening. Today is about who the 3 tenants are, because the moment you know them, that 100-headed mess we both drowned in last time starts, at last, to breathe.
And how small are we talking to go hunting for these 3? The proton is already the thing I picture as impossibly tiny, the speck buried inside the speck inside the atom. And now you want me to go inside that and find 3 smaller specks again, whirring about somewhere in there.
The whirring is the haunting part. Go down into the proton and it isn't empty in there. Quite the opposite. A tiny volume, crammed full and churning. 3 little things tearing round inside an interior that hums and never rests, dense the whole way through. And the arrangement, seen from outside, reads as one solid little dot, because dense is exactly what it is. Small inside, small inside, small. And never at any floor down, still.
All right, introduce me to my tenants then. What are the 3 little things whirring around inside every proton I happen to be made of?
They have a name, and the name is quark.
Quark. Say it again for me.
Quark. 1 syllable, near enough rhymes with cork. That's the thing that's actually fundamental, the quark. Your proton is 3 of them, and so is every neutron. And here's the first kindness the universe does us, after all of last week's cruelty. For everything ordinary, for you, this chair, the planet under it, the star it goes round, you only need 2 kinds of quark. Just 2.
2? Last week you buried me under 100+ so-called elementary things. I went home and had a proper lie down in a dark room. And now you stroll in and tell me the everyday world runs on 2.
2. That's the whole shopping list for ordinary matter. And mercifully this time, they've got plain names. Nobody had to reach for the Greek alphabet. The up quark and the down quark. That's it. Up and down. Those 2, in the right little groups, build every proton and every neutron in your body.
Just the 2 of them. For the whole of it. The entire planet, the sea, the air, me, all of ordinary creation running on a cast of 2.
The whole of ordinary creation, top to bottom, on a cast of 2. Every proton, every neutron, in every atom, in everything you have ever touched or been. Up quarks and down quarks, and nothing else called for in the everyday. After last week's 100, that ought to feel like a window thrown wide open.
Up and downloaded. And that's not up toward the sky or down toward the floor, I take it, just a pair of labels.
Just a pair of labels. 2 names to tell the 2 apart, nothing more. Don't go hunting for a real direction in it. There isn't one. Up quark, down quark. Think of them as 2 flavors of the same basic idea, the way vanilla and chocolate are 2 flavors of one ice cream. Now, the recipe. This is the bit I want you able to recite in your sleep, because we lean on it for the rest of the season. Ready for it?
Ready. Hit me with the recipe for a proton.
A proton is 2 up quarks and 1 down quark. That's the committee. 2 ups, 1 down. Were those 3 together in that little room, and what they add up to, what they behave as, seen from the outside, is 1 proton.
2 up quarks and 1 down quark makes a proton. Fine, I've got that. It's not complicated. And the neutron? The other brick. The one that sits in the nucleus right beside the proton but carries no charge at all.
The neutron is the same trick with the numbers turned round. A neutron is 2 down quarks and 1 up quark. So there it is. The proton is 2 ups and a down. The neutron is 2 downs and an up. Now look, really look, at how close those two recipes are sitting to one another.
They're almost the same. Proton, 2 up, 1 down. Neutron, 2 down, 1 up. The only difference between them is 1 quark. You've swapped a single up for a single down and nothing else has moved.
And there it is. You found it entirely on your own, and it's one of the loveliest things in the whole subject. Swap 1 quark for the other, flip a single down into an up, and the neutron you are holding is, in that instant, a proton. One kind of matter has just become another kind of matter. Nothing added from outside, nothing cracked open. Just one of the 3 tenants deciding to change which flavor it is.
Wait, that cannot be a small thing. You're telling me the difference between the 2 building blocks of everything, the 2 bricks the entire nucleus is made from, comes down to a single one of these little things flipping from the one flavor to the other.
A single one. That is the whole of the gap between a proton and a neutron. Everything else about them is identical.
One flip. That is the entire border between the 2 bricks that build every nucleus in existence.
The entire border. A single quark changing its mind about which flavor to be. Sit on the one side of that line and you're a proton. Sit on the other and you're a neutron. Step across it, the one to the other, and nothing else about you has to move an inch. It's the thinnest frontier in all of matter.
And can that actually happen out in the world, or is it just a tidy way to line the recipes up on paper? Like noticing 2 words are anagrams of each other and pretending it means something.
It genuinely happens. Out in the real world, a down quark can turn into an up quark, and when it does, a neutron becomes a proton. A real event going on inside matter all the time. How it happens, what does the flipping, the force that reaches in and changes a quark's very flavor, that's a whole episode of its own, further down the line. There's a shapeshifter loose in this story, and it's got its own night coming. For now, just hold on to the astonishment of it. Change 1 quark, and you change the brick.
I'll hold it, but you should know it's landed heavier than it looks. All right, 2 flavors, up and down. 2 recipes, 2 ups and a down for the proton, 2 downs and an up for the neutron. And a rumor that flipping just one of them turns the one brick into the other. That already feels like a full morning's work, and yet you've got the unmistakable look of a man about to make it a great deal worse.
I've got exactly that look, and you've earned every bit of the reason for it. Because there's a problem with these quarks. A real one. The kind that made perfectly sensible people flat out refuse to believe in them for years. And it's about charge.
Worse than fractional recipes, is it? Because I'll be honest, flip a single quark and the whole brick turns into the other one was already sitting right at the edge of what I can hold before breakfast.
Worse in a particular way. It breaks a promise you didn't even know you'd been given. The recipes are only counting. 2 of these, 1 of those, tot them up, done. What's coming next isn't counting at all. It's a rule you've leaned on your whole life, quietly cracking straight down the middle. So take a breath and steady yourself first.
Charge. Right, now charge I actually feel confident about, so let's watch you ruin that too. Charge is the thing that makes the wool sweater crackle, the thing that holds the electrons to a nucleus. The proton has 1 unit of it, positive. The electron has 1 unit, negative. Equal and opposite, the 2 of them. They balance out, the atom comes out neutral overall, and everyone goes home happy.
Everyone goes home happy, and underneath that happiness sits a rule so deep that nobody ever bothers to say it out loud. Charge comes in whole units. 1 or 2 or none, whole numbers always. You get a proton's worth, positive. You get an electron's worth, negative. What you never ever get is a piece of 1. Half a charge? A third of a charge? Nobody has ever caught such a thing crossing a room. Charge comes in whole coins, never in loose change.
Right, and that's not even a rule I was formally taught, so much as one I just quietly absorbed along the way. Whole numbers of charge, of course, everybody knows that. You'd no sooner run into a third of a charge wandering about than you'd run into a third of a person.
Everybody knows that, except apparently inside. Because the quarks, the very things making up your proton, do not obey it. So brace yourself, because this is the heresy sitting right at the center of the whole morning. The up quark does not carry a nice whole positive charge. It carries 2 parts in 3 of 1, 2/3 of a unit, a fraction.
2 parts in 3, so a piece of a charge, the exact thing you swore 10 seconds ago that nobody has ever once found crossing a room.
A piece of a charge. And the down quark is stranger still. It carries 1 part in 3 of a unit, a negative. A third of a charge, and pointing the wrong way round. So inside your proton, you've got 3 little things, and not a single one of them is carrying a respectable whole charge. They're all carrying change. Thirds. Odd little bits of a coin.
Okay, now I'm genuinely cross, because this flatly breaks the rule you set up 10 seconds ago. You told me charge comes in whole numbers and everybody knows it. Now you're telling me the things that everything is built out of carry thirds. Both of those cannot be true at once, so which is it? Pick one.
Both. Both are true, and the way they manage to be true at the same time is the most beautiful piece of bookkeeping in the subject. Watch what happens when you actually add the committee up. Take the proton. 2 up quarks, that's 2 parts in 3, and another 2 parts in 3. And 1 down quark, that's a third, negative, so you take it away. So, add 2/3 to 2/3, and then take away a third. Go on, do the sum out loud.
2/3 and 2/3 is 4/3. Then take away a third, and I'm left with 3/3, which is 1. 1 whole. Positive.
1 whole positive charge. Exactly what a proton has. Exactly what you have always measured on it. The thirds climbed inside, met one another, and conspired to come back out as a clean whole number. The fractions vanish in the adding. They eat their own oddness.
Hang on, let me do the neutron myself, because after that I don't quite trust it to behave. Neutron is 2 downs and an up. 2 down quarks, that's a third and a third, both negative, so 2/3 negative, and 1 up quark, 2/3 positive. So I've got 2/3 negative and 2/3 positive, and they cancel. Clean out, dead to nothing, 0.
0. Not a scrap of charge left over. The neutral neutron. And now you can see with your own eyes precisely why it's neutral. Its thirds cancel each other to nothing at all. And do you feel what just happened in your own arithmetic? You added up fractions that supposedly can't even exist, and out came the honest, plain, whole numbers you have measured your entire life.
I do feel it, and it's a strange feeling to sit in. It's like being told the tidy, round bill I always pay at the counter is secretly settled in thirds of a penny somewhere in the back, and it only ever adds up to whole pennies by the time it reaches my hand.
That's the trick, precisely. And it isn't sleight of hand, it's genuinely how nature keeps its books. Fractions inside, whole numbers out. The thirds are real, they're truly in there doing their work, but they arrange themselves so that anything that ever walks out into the open, anything you can actually catch and measure, carries a clean whole charge. Nature keeps all the loose change in the back room and only ever hands you round coins at the till.
Round coins at the till. So, from where I'm standing, at the counter, I'd never once see the thirds. I'd only ever be handed the neat whole change, and I'd swear blind that's all there ever was to it.
You'd swear it on everything you own, and you'd be wrong. and you'd have no way at all of knowing you were wrong. The whole numbers are honest, they just aren't the whole of the story. That gap between what you can catch at the till and what's really going on in the back room is exactly where the truth managed to hide for so long.
Which is presumably a good part of why nobody believed in these things for years. If the fractions never leak out, if every single thing you can measure carries a whole charge, then the thirds are completely invisible from the outside. You could spend a lifetime measuring nothing but whole numbers and never once guess there were thirds hiding underneath the whole time.
That's exactly why. The evidence on the table was all whole numbers, and the true answer underneath was all thirds, and it took real nerve for anyone to stand up and say, what if the visible whole is built out of invisible fractions that simply can't come out on their own? Which, you might already have noticed, is the same shape as not being able to take one quark out of the box. The thirds and the never alone. They're the same secret, wearing two different coats. But hold that thought close, because we've a pattern to go and meet first.
The same secret in two coats. That's a lovely and slightly sinister way to put it. The thirds I can't spend and the quark I can't hold, both of them refusing, each in their own fashion, to come out into the daylight alone.
Both of them shy of the daylight, in precisely the same manner. And that is not the last time this season you'll meet that particular shyness. But you're right. I owe you something bigger before we get anywhere near it, and it's badly overdue. So set the thirds down gently for a moment and let me finally pay off the debt from last week.
We do, and I have been waiting for it, because you made me a promise last time. You dropped me off, at the end of last episode, with 100+ particles and a splitting headache, and you told me the mess wasn't a disaster, it was a clue, and it was shaped like the periodic table. I have been carrying that, trust me, it's a clue, around ever since, like an IOU I wasn't sure you'd honour. So, are you finally paying it?
I'm paying it in full, and with interest. This is the moment the whole crowd from last week falls into line. So put yourself back in the middle of that mess for a second. Over 100 particles raining out of the sky and pouring out of the machines, all of them heavier cousins of the proton and the neutron, every single one called elementary, and no two of them making the least bit of sense side by side. A zoo, a shelf of unrelated animals with nothing in common but the shelf. You remember the despair of it.
Vividly. It was a junk drawer the size of a warehouse. Every particle its own special snowflake, no two alike, and all of them stamped elementary, the smallest possible thing, the end of the line, when there were more than 100 of them. That was the flat contradiction you cheerfully left me chewing on all week.
Now watch the drawer tidy itself. Here is the single idea that does the whole job. Take that entire heavy crowd, the 100+, and stop treating each one as its own separate, irreducible thing. Say instead, each of these is just a few quarks, stuck together in one particular combination. This one's a certain 3 quarks. That one over there's a quark paired up with an anti-quark. This heavier fellow's a different 3 again. The same small handful of quarks, over and over, arranged and rearranged.
So they're not 100 different fundamental things at all. They're 100 different recipes. The same few ingredients out of the same little pantry, just shuffled into different dishes.
100 recipes from a tiny pantry. That's it exactly. And the very instant you start seeing them that way, as combinations rather than as separate creatures, the zoo stops being a junk drawer. The particles slide into families. The ones built the same way settle down next to each other. You get rows, you get columns. Line them all up by how they're put together and by how heavy they are, and the mess arranges itself, almost on its own, into neat little tables. Patterns, repeating, orderly, sane.
Rows and columns. You're building me a periodic table for particles.
A periodic table for particles. That is precisely what it is, and precisely what the people who first saw it called it. The pattern even earned a name, the Eightfold Way, for the tidy, symmetric little groupings the particles kept falling into. And the man who saw it clearest of all, who first read the whole zoo as combinations and laid the families out in their rows, was named Gell-Mann. He's the one who looked into the junk drawer everyone else was despairing over and saw, sitting right there, the filing system.
And this is the thing you promised me. The periodic table pulled off this exact move once before, didn't it? The elements were a baffling, endless list, and then all at once they snapped into rows, and the rows turned out to mean something real. They were the fingerprint of hidden parts.
The fingerprint of hidden parts. The elements fell into rows because each atom was secretly built from a few smaller pieces, and the rows were quietly counting those pieces off. And here is the same tell, one whole floor further down. The particles fall into rows because each one is secretly built from a few quarks, and the rows are counting the quarks. Last time, the pattern meant there's an inside. This time, it means precisely the same thing. It always means the same thing.
So the clue really was a clue. The mess really was pointing at something underneath. When a bewildering, hopeless list suddenly snaps into neat rows, that's the universe leaning over and telling you there are parts underneath that you simply haven't met yet.
Every single time. A pattern that clean is never a coincidence. It's a confession. And now I get to show you the moment this whole thing stopped being a nice, satisfying filing system and became something that gave people genuine chills. Because here is what a real pattern does. The exact thing that separates a true law of nature from a lucky accident. Look hard at the table Gell-Mann had laid out. And there was a gap in it.
A gap, an empty square, sitting there in the middle of the grid.
An empty chair at the table. Every other seat filled with a known particle. This one, that one, all of them accounted for. And then one seat, right where the pattern says a guest should be. Empty. And you can do one of two things with an empty seat in a pattern that good. You can shrug and say the pattern's only roughly true, near enough is good enough. Or you can trust it all the way down to the floor and say, something belongs in that chair. Something real. Something we simply haven't found yet. And Gell-Mann trusted it all the way down.
Trusted an empty square. Trusted a hole in a grid more than he trusted his own caution.
More than he trusted the whole crowd of particles he could already see, in a way. Because anyone can believe in the guests who've already turned up to the party. It takes real conviction in a pattern to believe just as hard in the one who hasn't, and to bet out loud on the shape of the empty chair.
So he pointed straight at the empty square and said, "There's a particle missing. There has to be one right there."
More than that, and this is the part that lifts the hairs on your arm, because the pattern didn't just say a particle was missing, it said what that particle had to be. Where the empty seat sat in the grid told him its charge. How the rows climbed steadily in heft told him roughly how heavy it would have to be. He could describe, in real detail, a thing that no one had ever laid eyes on. Its charge, its weight, out of nothing but the shape of the empty space in the pattern. He said, in effect, there's a chair missing at this table, so lay a place for it. Here's the name card. Here is exactly who's coming to dinner.
Lay a place for a guest you have never met, described down to the details entirely from the shape of the gap where they ought to be sitting. That is either magnificent or completely mad, and I strongly suspect you're about to tell me which one it turned out to be.
They went looking, and they found it, sitting exactly where the gap had said it would sit, carrying the precise charge the pattern had demanded, weighing near enough what the climbing rows had foretold. The empty chair got filled by precisely the guest the pattern had ordered up, sight completely unseen. And that, Right there is the moment a filing system quietly becomes a law of nature.
Because it predicted. That's the whole thing. It didn't just tidy up what was already sitting on the table, it reached forward into the unknown and told you what you were going to find before anybody had found it.
That's the entire difference, and you've put your finger dead on it. Tidying is cheap. Anybody can sort a drawer after the fact and feel clever about it. Predicting is the real thing, the thing you can't fake. A pattern that only organizes what you already have in hand might just be a coincidence, dressed up nicely for the occasion. But a pattern that says, go and look over there and you'll find a thing with these exact properties, and is then proven right, that pattern is telling the honest truth about how the world is put together underneath. The quarks were real, and the proof of it was a chair laid for a guest who actually walked in the door.
And that pays the IOU completely, with the interest you promised. Last week's mess was never a mess. It was the pattern of the hidden parts showing faintly through, exactly like the elements did. And once somebody finally read it properly, it went and told the future. I feel like I've been let in on the ending of a mystery novel, and honestly, it's better than I'd let myself hope.
It's one of the truly great detective stories, and you're right to sit and enjoy it. But I promised you honesty this whole season, not just the triumphs, and there are two honest edges I need to sand down before you get too comfortable. The picture I've handed you so far is a shade too clean, too pleased with itself, and I'd much rather you walked out with the true shape of the thing.
I can feel a but coming, and after this morning I've learned to brace hard for your buts. Out with it.
A fair bit of bracing, yes. Nothing here undoes what you've already got. The quarks are real, the pattern predicts. All of that stands firm. It's only that the neat little story of 2 quarks and you're done has 2 loose threads hanging off it, and I'd be dishonest to quietly tuck them out of your sight. So let me pull on both of them, gently, one at a time.
Go on then, rough it up for me. Where does the tidy story quietly leak?
First edge. I told you that ordinary matter runs on just 2 quarks, up and down. And that's true, every word of it. That's your whole everyday world, top to bottom. But the zoo, if you remember, had heavier members. Odd, weighty particles that flared into being in the collisions and then vanished again almost as fast as they'd arrived, gone before you'd finished naming them. And building those needed more than up and down. It needed a few heavier kinds of quarks.
More quarks. So it isn't quite just up and down after all. You gave me 2 and now you're walking some of it back.
For the everyday world, it is genuinely just up and down. Hold tight to that, it's true, and it matters enormously. But the full zoo, the rare and the fleeting bits of it, needed a few extra quarks. Heavier, shyer cousins of the up and the down. Same basic idea, a good deal more heft to them, and far, far less keen to hang about in the world. They don't build you, or the chair, or the star overhead. They turn up only in the rare, quick-to-vanish members of the zoo, and then they're gone again. Think of them as cousins who genuinely exist, who you ought to know exist, but who never ever come to the everyday dinner.
Heavier, shyer cousins. All right, and how many of these cousins are we talking about? Are you about to bury me under another 100, right when I'd got my breath back?
No Greek alphabet this time, you have my word. It's a small handful more, and I'm deliberately not going to drill the full guest list into you tonight, because the exact count genuinely isn't the point, and you'd only end up resenting me for it. The point is simply this: up and down for everything you can touch, plus a few heavier cousins the universe keeps quietly on hand for special occasions. That's the honest shape of the quark family. We'll leave it right there for now.
I can happily live with a few heavier cousins, details to follow. That is a far kinder junk drawer than the one you left me with last week. So what's the second edge? The important one.
The second edge is the one that actually matters most, and it's the one people get wrong more often than any other, so I want it perfectly clean. Everything I've told you so far, the proton, the neutron, the whole heavy zoo, all of it is quarks in combination. So it would be the most natural thing in the world for you to leap now to the conclusion that everything is made of quarks. Every particle, bricks all the way down, quarks waiting at the bottom of each and every one.
That's exactly where I was already heading. Yes, I won't pretend otherwise. If quarks are the real ground floor, then surely everything at all is standing on them. Go on, don't you dare tell me the electron's secretly a committee too.
The electron is not a committee. And this is the honest edge I really, truly don't want you to blur, so listen close. Take an electron, the little thing whizzing round the outside of every atom, the thing that makes your sweater crackle in the dark, and go looking inside it, exactly the way we went looking inside the proton. Shrink yourself down, step in, hunt about for the three little tenants, and there is simply nobody home. No parts, no committee, no thirds tucked away in a back room. You look as hard as it is physically possible to look, with the finest tools ever built, and the electron shows you nothing inside itself at all.
Nothing. So the electron really is the thing the proton was only pretending to be all along, an actual, honest brick.
An actual, honest brick. As far as anyone has ever managed to see, and people have looked ferociously hard, the electron is genuinely partless. A real end of the line. Elementary in the full, proper sense the word is supposed to carry. It isn't made of quarks. It isn't made of anything smaller. It just is. So the zoo splits cleanly into two quite different kinds of resident, and you must not let them blur together in your head. Most of the crowd, the proton, the neutron, all those heavy cousins, are quark combinations. Committees, every one. But the electron, and a small clan of relatives all its own, stand completely apart. Genuinely fundamental. Not built from quarks. Not built from anything.
So the zoo has two quite different kinds of animal in it after all, the ones with an inside and the ones without. And I mustn't lump the two together, however tempting the tidier version is.
Mustn't ever, because the difference between them is the whole point of the night. One kind is a committee wearing the costume of a single thing. The other kind is genuinely, all the way down, a single thing. Blur those two together to keep your diagram tidy, and you've thrown away the very distinction this whole episode exists to draw.
So when you abandoned me last week with 100 elementary things, the real fix isn't, none of them were elementary after all. It's subtler than that. It's most of them weren't. They were quark committees wearing costumes. But a few of them, like the electron, really were the genuine article the whole time.
That is the fix, exactly, and you've stated it a good deal better than I was about to. The word elementary was never actually wrong. It was just being handed out far too freely, pinned onto anything that came through the door. Strip away all the imposters, the 100 committees busily pretending to be single, indivisible things, and what you're left holding is a short, honest list of the truly partless, a few quarks, and the electron and its little clan. That is the real ground floor. Small, honest. The 100 was only ever a crowd of costumes thrown over a small handful of actors.
A handful of actors and 100 costumes. That's the line I'm carrying home tonight. That one's mine now. So the electron gets to keep its dignity through all of this. It isn't three of anything. It isn't a committee. It's just quietly, stubbornly itself.
It keeps its dignity entirely, and you do well to give it a small nod of respect on the way past. It's one of the very few things in this whole sprawling story that is honestly, all the way down, exactly what it appears to be. So don't build it out of quarks, or tuck a secret committee inside it to keep things tidy. It stands on its own 2 feet, and it is going to matter, later on, that it does.
Noted. and honestly, a little reassuring, all things considered. I rather like that something in this picture is simply exactly what it says on the tin. All right, you've handed me the tenants, the recipes, the thirds that add up to whole numbers, the pattern that told the future, and now 2 honest edges. The mess from last week has genuinely resolved into something I could very nearly draw on the back of an envelope. So, why do I get the distinct feeling you've been quietly saving the strangest thing of all for the walk to the door?
Because I have been, and you're quite right to feel it coming. Everything so far has been the tidy, triumphant half of the story. A few things make 100, the pattern predicts the future, the electron stands there being honest. All lovely. But there is one rule left, and it's the one that makes quarks unlike absolutely anything else you will ever meet in your life. It's the rule I flagged right at the very start of the morning and then deliberately walked away from. The one about the box you cannot open.
The never taking one out thing. Yes. I have been waiting, more or less patiently, for you to circle back round to that, because it has been quietly nagging at me the entire time. You keep telling me there are 3 quarks in the proton, 3 separate, distinct things. And in the same breath, you keep telling me I can't have one of them. Those 2 facts flatly refuse the sit down together in the same head.
They do refuse, and they're not supposed to sit together comfortably yet. That squirm of discomfort you're feeling is precisely the correct response. So let's make it worse, in the most instructive possible way. You can absolutely put quarks together. That's been the whole thrust of the episode. 3 of them make a proton, 3 make a neutron. A quark and an anti-quark clap together to make other members of the zoo entirely. Combining is easy. Nature does it constantly, everywhere, all the time. Combining is not the problem, not even slightly.
Combining is fine. It's the separating that's forbidden. So let me actually roll my sleeves up and try it then. I'm inside the proton, 3 quarks whirring merrily about. I reach in, get myself a good firm grip on one of them, and I pull. Steady, patient, firm pull. What happens? Does it just not budge? Is it welded in place?
Oh, it budges. That's the cruel part. You pull, and it starts to come. The quark you've grabbed hold of moves away from the other 2, and for one glorious moment, you honestly think you've got it. You think you're finally about to lift a single lone quark up into the open air, where no one in the history of the world has ever held one. And then?
And then? Don't stop there. Go on.
And then, before it ever quite comes free, a brand new quark appears out of nowhere on the end of the one you're pulling, with a fresh partner to go with it. Your pull doesn't tear a quark loose from the group. Your pull makes more of them. You reach in for one, and you come away with your hand full of new ones, freshly minted, still bound up tight in their little groups. The lone quark you were so sure you had is gone in the very instant you'd have had it, replaced, quick as a blink, by another huddle.
Hold on. I pull on one to get it alone, and it multiplies. I reach in for a single quark, 1 quark, and the universe hands me back 2 more instead of just letting me keep the one I'd caught.
It multiplies right there in your hand every time. It is, without competition, the least cooperative thing in physics.
That's not a particle, George. That's a gremlin. That is the thing you're told, very firmly, never to feed after midnight. You reach out to pick just one of them up, and suddenly there are 3 where there was 1, and you're somehow worse off than when you started the whole business. I wanted a single, lone quark, and I've managed only to make the crowd bigger.
A gremlin is honestly not a bad picture at all, and you're very welcome to keep it. It'll serve you well. Pull on a quark to isolate it, and instead of one, alone, you breed yourself a fresh new pair. And the harder you pull, the more stubbornly you insist on having just one all to yourself, the more brand new ones you conjure up, and never, not once, a single quark standing alone in the open. They come in twos, they come in threes, never ever in ones.
So every single time I reach for the lone quark, it's gone before I can even close my fingers. And I've only made the whole problem worse by daring to try. That is genuinely maddening to sit with. The most fundamental thing there is, the actual, literal ground floor of everything. And it's the one and only thing in the universe I am forbidden from ever holding up by itself.
Sit in that for a moment, because it truly is one of the very oddest facts in all of science, and it deserves a moment. The things we are calling the most fundamental, the true, partless, bottom of absolutely everything building blocks, are the one single kind of thing you can never manage to get on its own to look at. You can have two of them, you can have three. You cannot, by any means anyone has ever devised, have one. The deepest layer of the whole world turns out to be the one layer nature will not, under any circumstances, let you hold up to the light alone.
There's that word again. Reason. You keep setting reasons down just out of my reach, like a plate I'm told I'm not allowed to touch yet.
I do, and I'll admit it's a little maddening from where you're sitting. But some of these reasons are big enough that handing them over in passing would be a genuine waste. You'd nod along and never feel the real weight of them. This is very much one of those. It wants a proper run-up, not a scrap tossed over my shoulder on the way out.
And I'm guessing, going purely off the look on your face right now, that you are once again infuriatingly not going to tell me why.
Once again, no. And this time it genuinely isn't me being coy for the fun of it. It's me keeping the best single story in the entire season intact, so that it can land properly when its moment comes. There is a reason. A real, specific, and a frankly gorgeous rule sitting underneath all of this. The reason quarks can only ever huddle together in twos and threes and never once stand alone. It has a hidden ingredient we haven't so much as named tonight. And when we finally do crack it open and lay it out, it is going to be one of the most satisfying evenings the two of us spend together, anywhere in this whole series. If I blurt it out now, in a rush, on the way out the door, I will spoil it completely. So I am going to make you wait for it.
You are a cruel man with an impeccable sense of timing, and, grudgingly, I'll allow it. But give me at least the bare shape of the promise, so I've got something to hold on the way home.
The shape of the promise is this. There's a rule, buried deep in how quarks feel one another across the little gap between them, that makes pulling them apart cost more and more the further they get. Not less, as you'd expect, but more. So much more in the end that the universe would genuinely rather spend that effort making brand new quarks out of thin air than ever let one of the old ones come free. That's why they multiply in your hand. That's why the box will not open. What the hidden ingredient actually is, and why it behaves so utterly unlike anything else in nature, that's an evening entirely its own, further down the season. Tonight, just carry the wonder of the thing. The ground floor comes only ever in groups.
The ground floor comes only ever in groups. All right, that I can carry, and it does something rather nice actually, now that I turn it over. It means my very first instinct this morning, oh, let me just take one out and have a proper look at it, was doomed from the very first second I said it. I was never once going to get to hold a brick in my hand, because the bricks, it turns out, will not be held.
You were doomed from the very first second, and I quietly let you walk straight into it on purpose, because feeling the wall with your own hands is honestly the only way to truly believe it's really there. Now, let me help you gather up what you're actually carrying out the door tonight, because it's a great deal more than you carried in. You walked in this morning made of solid little bricks. You're walking out made of committees, 3 quarks to a proton, 3 quarks to a neutron, restless and humming, dense and never still, somehow holding its shape.
Made of committees. 2 flavors of quark for everything ordinary, up and down, With a small handful of heavier cousins, the universe keeps tucked away for special occasions only.
2 ups and a down for the proton, 2 downs and an up for the neutron, and flip just a single quark from the one flavor over to the other, and the one brick becomes the other, a promise we'll keep further down the road.
Charge that comes, scandalously, in thirds on the inside. 2 parts in 3 on the up quark, 1 part in 3 on the down. Thirds that add themselves up so that only clean, respectable whole numbers ever actually walk out the door.
Fractions in the back room, round coins at the till. And the pattern, the periodic table for particles, the eightfold way, Gell-Mann's beautiful filing system, which didn't only tidy the whole zoo into rows, but went and laid a place at the table for a guest nobody had ever met, and then watched that guest walk in.
The empty chair, filled by exactly the diner the pattern had ordered. And the electron, keeping its own quiet counsel through the whole affair. Not a committee at all, but a true, partless brick, genuinely elementary, standing well apart from the entire quark crowd.
And over the top of all of it, the one strange rule you carry out above everything else. You can build with quarks to your heart's content, but you can never once hold a single one alone. Pull, and you only ever breed more of them, never fewer. The most fundamental things there are come only ever in company.
And the pattern's still the part that gets me the most, if I'm honest. Not that it tidied the mess into rows, but that it dared to speak up about what wasn't even there yet, and turned out to be right.
Hold on to that instinct, because it's the whole spirit of the road ahead of us. A pattern good enough to predict is a pattern that has quietly understood something true about the machinery underneath. And we've barely started reading this one. There are more empty chairs in this story, and more guests still waiting to walk in through the door.
It's a good haul for a morning, and it feels, for the first time since you tipped that whole zoo out over my head last week, like the floor is finally back underneath my feet. A lower floor than I'd thought, made of far stranger stuff than I'd thought, but solid enough, in its odd way, to stand on. Quarks and electrons. A few small things, quietly making the whole 100. I could very nearly rest there and call it done.
You could very nearly rest there, and I'd honestly let you. Except there's a shock still waiting, and this one has nothing whatsoever to do with size, or with how many little pieces it takes to make a proton. We've spent the entire morning burrowing smaller, inside the brick, inside the committee, all the way down to the quark. But the next surprise isn't tucked underneath anything at all. It's been standing right beside everything you've met today, the whole time, and you never once noticed it there.
Nothing to do with size. That's almost worse somehow. You've spent the whole morning patiently teaching me to look smaller, and smaller again. And now you tell me the next shock isn't down there at all.
Not down there. Not a smaller piece, not a deeper flaw beneath the floor. This one's been hiding in plain sight the entire time, right out at the same level as everything you already know. The proton, the quark, the honest little electron. You've been looking straight past it all morning, precisely because it wears such an ordinary face.
Beside everything. What on earth do you mean, the side? I've had my head down, looking inward and downward all morning long. What have I been missing, off to the side, this whole time?
A twin. Every single thing you have met today, every quark, up or down or heavy shy cousin, and the electron too, your honest little partless brick. Every last one of them has a mirror twin. Something identical to it in very nearly every way you could name, but carrying the exact opposite charge. A matching partner you've never once been introduced to, standing patiently just out of frame for every particle in the whole of this story.
A mirror twin with the opposite charge for everything. So there's an entire second cast I haven't so much as glimpsed. A shadow version of the up quark, a shadow of the electron, a shadow of every bit of it.
a whole mirror cast, waiting in the wings. And here's the thing that ought to keep you up tonight. The exact reason I've held it back for the door. It isn't merely that the twin exists, quietly, off to one side, minding its own business. It's what happens if a thing ever actually meets its twin.
I'm almost afraid to ask, given how this morning has gone. Go on then, what happens when a particle meets its own mirror?
They don't collide. They don't bounce off one another. They don't stick together. They don't do any of the ordinary, sensible things two objects do when they meet in the world. If a particle ever so much as touches its twin, they both simply vanish. Gone. The two of them wink clean out of existence entirely. Matter and mirror matter cancelling each other out to precisely nothing. And all that's left behind, in the place where the two of them were, is a flash of light.
They annihilate. The two of them just quietly destroy one another and leave a little flash of light where there used to be. So there's a version of every single thing I am made of, walking around out there somewhere, that would erase me completely on contact.
That is the mirror world, and it is exactly where the two of us are going next. The stuff that is the perfect, flawless opposite of you, that meets ordinary matter and simply ends it in a flash. We've spent all of today carefully finding the few small things you're built out of. Next time, we go and find the thing that could unbuild them again completely, just by brushing up against them. And why, if the mirror really is such a perfect match, the whole universe somehow ended up so lopsidedly full of the one and so strangely empty of the other.
A mirror twin for every piece of me, one that ends matter on contact. And I'm only hearing about it now, on the way out the door. A deeply unfair place to leave a person standing. But I'll take the trade gladly, because I walked in a solid little brick, and I'm walking out a committee of 3, restless and humming, and never still, carrying thirds of a charge I can never spend, and standing on a ground floor I can never pick up and hold. So I'll sit with the 3 inside me, and the one I can never hold alone, and next time, apparently, I go and meet the thing that would destroy me. See you at the door.